Assalamualaikum warahmatullahi taala wabarakatuh. We are from K13 and we are going to present our final year design project with the title Production of Thymol from Glycerol. So, for a little bit of introduction, the physical and chemical properties of thymol is the molecular weight of thymol is 150.221 gram per mole. The melting point is 49 to 51 degrees Celsius and boiling point is 232 degrees Celsius. The flash point of thymol is 102 degrees Celsius. The density is 0.96 gram per centimeter cube and the specific heat is 9.76 joule per kilogram per Kelvin. So the usage of thymol is an antiseptic in mouthwash as an alcohol solution and the industry powders for the treatment of tinea or ringworm infections, as a medical disinfectant and general purpose disinfectant, and as a rapidly degrading non-persisting pesticide. The raw material of our plant is glycerol, and the glycerol is from the palm oil mill effluent. So for our process description of our plant is we use CSTR as our reactor. So for the CSTR1 is reaction between hydrogen gas and glycerol to produce propane. And the second reactor is CSTR 103 and 104, which is the process of dehydrogenation of propane to produce propylene. And for the CSTR 105 and 106 is the reaction between propylene and amcrazole to produce thymol. So for our byproduct is amcrazole to waste disposal, and propane goes to the waste disposal, and wastewater goes to the wastewater treatment. So this is our process flow diagram of our plant. And the separators are added in order to recycle most of amcrazole and propane to both reactors.
So for heat integration, there is a summary of heat integration, which is heat for hot stream is 20 kilowatt, for cold stream is 19 kilowatt. So we set the minimum temperature for 20 degrees Celsius. The pinch temperature is 120 degrees Celsius. Pinch temperature for hot stream is 130 degrees Celsius. Pinch temperature for cold stream is 110 degrees Celsius. The energy requirement before the heat analysis was conducted is 1,877 kilowatt. After the energy requirement is around 1,530 kilowatt. So the total energy recovery is around 18%. For the economic potential, we can see there is a graph for FPE2, FPE3 and FPE4. The cost for raw material is around 45 million, reactor cost 30 million, compressor cost 2 million, and for total separation unit cost is around 5 million. For the economic analysis, there is two, which is total capital investment, total production cost. For the fixed capital investment is around 52 million. Total capital investment is around 99 million. Next is for cost of manufacturing, which is involved direct manufacturing cost, fixed manufacturing cost, plant overhead cost, which is the total of cost of manufacturing is 82 million. Last is the research and development, distribution and marketing, administrative expenses, which is around 743,550,000, which is the total production cost is around 83 million. Next is the summary of the project investment. For the MARR is 0.2. Return of investment is 0.52. Payback period reference is 3.5 years. Payback period project is 1.07 years. For the net present value is around 161 million per year. So as you can see, the payback period reference is larger than payback period calculated. So it's concluded as valid. And the return of investment is larger than MARR. So it also acceptable. We set the thymol sale price as 10 ringgit per kilogram. So we get the gross profit margin around 56% and net profit margin around 19%.
Next is a process control. Okay, the objective to implement a control system is to ensure the safety of the plant and to achieve a stable production rate as well as desired product quality. So, in this table, we have 4 control parameters, which is temperature, pH, pressure, and level controller. For temperature controller, the unit involved is reactor, flash column, distillation column, furnace, and heat exchanger. pH controller, unit involved is reactor. Pressure controller, unit involved is reactor, separator, flash column, furnace. For level controller, the unit involved is separator, distillation column, flash column, and lastly, distillation column 2.
For heat integrations, there is the summary from the previous heat analysis. So as you can see, there is total energy recovery, which is around 80%, and this is the PFD after heat integration.
Okay, that's result for reactor 1. There are 2 guide words. Okay, first is no. No reduction is no flow cause. The cause is valve fail to close. No propane is produced and pipe is blocked. The consequence, no propane sent to a separator. The action require add additional bypass valve in a parallel to valve. The second guideword is less, division is less flow, the causes is above 1, partially closed, part partially blocked, and pipe rupture. The consequence is quantity of the propane is below than required process condition. So action required is add additional bypass path in a parallel to bath. Next.
Okay, so for waste management, basically we have two ways, which is waste gas propane and wastewater. For waste gas can be purged because the concentration is 179.24 ppm, and the wastewater will be going through wastewater treatment because of the high COD and BOD. So for propane gas has 23.96 kg per hour as flow rate, and while wastewater the total has 211.33 kg per hour. So for the catchment area, we'll be choosing Sungai Chewang, and we'll process the waste according to the standard B. So the organic matter present in effluent is glycerol. Molar, for the assumption we do is molar density of the waste stream follows the pure water, and the BOD value is assumed to be 0.5 COD value. Okay. So for the BOD and COD value of our wastewater is 45,249.65 mg per liter, and for COD is 90,499.30 mg per liter. Next. This is the PFD of our wastewater treatment. So what I have to for the improvement is that we add a filter press to remove the impurities and return the water to the equalization tank, and also add the flow of the RAS return to each of the aeration tank. Next, then we have corrected the efficiency of COD and BOD removal of each unit used, such as the equalization tank and primary clarifier. Okay, next.
Next is for acts and regulations. 3 regulations are applied for our plant process. Firstly is control of industrial major accident hazards 1996, because we use hazardous substance in the process, which is hydrogen with 932 tons. Since our plant process hazardous substance more than threshold quantity, then our production plant is a MHI. Next is safety health regulation 1987 is applied because our project is a chemical industry with more than 100 employees. Lastly, factories and machinery regulation 1986 in regulation 5 and regulation 10 are applied for our plant process. Next. So this is our plant layout for our process. Raw materials such as glycerol, hydrogen, and M-cresol are placed at the middle to reduce the loss potential from an explosion or fire that may spill flammable. This area also categorized as restricted area. The production site is located at the middle beside to raw material storage of the site to minimize any incidents such as fatality and damage. The waste treatment facility, which consists of wastewater treatment plant is located at beside of production plant. Many hazardous substances in this area. Stack for the emission of flue gas is built at far the northeast end of the site plant. The wind blowing to northeast will not cause the gas emitted from the stack blowing back to the production plant. Next. So next is design of heat exchanger, which is a cooler. Inlet temperature of the cooler is 300 degrees Celsius with pressure 10 bar, while outlet temperature is 32 degrees with pressure 10 bar. The flow rate for both stream is 2,992.66 kg per hour, where the tube side is steam and the shell side is M-cresol, propylene, and thymol. Some calculations have been performed to find values for designing a cooler. So this is, okay, next. So this is the mechanical design for cooler. The wall thickness is 6.35 mm. The corrosion allowance, which is 3 mm, is added as additional method to the corrosion material as high temperature and pressure condition. Design pressure is 10 bar. Design temperature is 300 degrees Celsius. Material vessel is a carbon steel SA516 as the construction material. The drawing shows a side view and top view of heat exchanger, saddle support, cross-sectional view of tube bundles, tube side and shell side of fluid flange.
Of heat exchanger 101. Okay, the function of heater in our plant is to heat up the glycerol from temperature 32 degrees Celsius to 360 degrees Celsius. With the composition, with the mass flow rate is 628.46 kg per hour. So I decided to use the spring grid floating head with shell pulse 1 unit, tube pulse 8 unit, number of tube 27 unit, material is copper nickel, outer diameter is 21 mm, inside diameter is 15.2 mm, length is 4 meter, pitch is 26.25 mm, heat transfer area is 6.94 meter square, shell inside diameter is 30 mm, cut is 25 Cube coefficient is 2724 watt per meter degree Celsius. For shell, coefficient is 415.26 watt per meter degree Celsius. Overall coefficient is 294 watt per meter degree Celsius. Tube pressure drop is 35.52 kilopascal. Shell pressure drop is 42.75 kilopascal. So this is the mechanical drawing of a heater, okay, with the top view, front view, cross-sectional view of the tube bundle, saddle support, webbing, a flange view with a standard saddle design and a flange design.
Is the design of the phase separator. The inlet of this phase separator is glycerol, water and propane. And the top outlet is propane gas, and the bottom outlet is the mixture of glycerol and water. So this is the detail of the design. For the material, I choose to use stainless steel, and the height is 2.535 meter, diameter is 0.353 meter, thickness is 5 millimeter, MEWP for the vessel is 3,310 kilopascal. For the weight load, the deck weight is 10 kilonewton. For the support, I choose the type of straight skirt 90 degree. Material is plain carbon steel. Height is 1 meter. For the flange, fit, I choose the type of welding neck. Bolt number 4. Top is welding neck. Bolt number 4. Bottom is welding neck. Bolt number 8. And there is manhole line. Bolt number 16. So these are the design that I made. So as you can see, there is a specification and the dimension of the welding neck flange, which is I refer to the standard dimensions.
Okay, so this is the detailed design of a distillation column. The function of distillation column is to separate the glycerol from the water while remain high purity. So the flow rate of glycerol from the will come out as a heavy key from the bottom with 47.13 kg per hour, while water will come out as a light key from the distillate with 190.62 kg per hour. So the operating temperature for the distillation column is 100 Celsius, while the pressure is 1 bar. The material I chosen is carbon steel SA62 because it is cheaper. For the vessel internal diameter is 0.6985 meter, and the head and bottom height is 0.1746 meter, while the vessel shear height is 9.3855, and vessel wall thickness is 10.1227 millimeter. For the MAWP of vessel, we have the 232.3565 psi, and for the stress analysis is 11.5268, which is less than 18,900, and the elastic stability is 1.5692, which is less than 111.65, which proven that the design is safe. So the type of vessel support I chosen is straight skirt support, and the skirt diameter is 698.5 meter, and for the bolt number for base ring is 8, then bolt circle diameter is 1134.5 millimeter, and base ring thickness is 37.73 millimeter. The type of flange joint I chose is welding neck flange. So next. So here is the mechanical drawing of distillation column. We have the cross-section view of distillation column, top view of column, side view of tray, top view of base ring, top view of tray, cross-sectional view of skirt, main hole, and cross-sectional view of flange. And the dimension of flange, the standard I use. Next.
Design of the in order to heat up the propane gas up to the 636.85 degrees Celsius using furnace with the operating temperature 1 bar. So based on calculation, the number of tubes for furnace is 20 is 0.08 meter, meter is 0.03 meter, and the tube inside the diameter is 0.02 meter. The tube effective length is 0.70 meter, the width is 0.79 meter, and also height 0.79, and the wall thickness of the furnace is 0.001 meter. The insulated thickness is 0.00025 meter, and the tube arrangement of a furnace is direct one row tube. The material that select is silica brick, and also for the insulator is fire clay insulating brick. Next. So this is the mechanical design of the furnace with the cross-sectional view of furnace, and also the left side view of the furnace. And the welding net flange, I choose flange with the class 150 with the nominal size 1.5 inch.
improvement, okay, we have improved by remove the composition controller as it is not necessary to have it in our process. Heat exchanger is added at the split stream reactor 1. Maintain the M-cresol disposal because there is just small amount of M-cresol impurity that need to dispose and larger percent of high purity M-cresol in recycle back to the stream. Corrected efficiency of COD and BOD removal of each unit used. Besides, filter press is added in the wastewater treatment PFD. The flow of rise return to each of the aeration tank are added. The typo in the stream typo is corrected with the actual inlet and outlet temperature. Connect the liquid level controller at the top 3 of distillation column. Remove the pressure controller from the outlet stream of reactor 1. We have fixed the error of the value in the simulation. We have fixed according to the correct title order. Relief valve was added. Fix the final report according to the Gaia UKM. As a conclusion, our plant is producing thymol in accession oil. We are using glycerol as our raw material. The plant capacity of thymol for our plant is 2,305.5 kg per hour, which is equal to 19,640 tons per year. Wastewater treatment is carried out biologically since our wastewater effluent is biodegradable. Wastewater is able to be treated as a COD and BOD, which is 22.91 mg per liter and 45.82 mg per liter respectively, which is under the limitation required to release according to the standard B. Finally, in economic analysis, the estimated capital investment and the total product cost is 54 million and 83 million respectively. The estimated payback period is 1.07 years and the net present value show a positive value which is 169 million. Meanwhile, the discounted cash flow rate of the return is 0.4997. The plant location was selected based on a deep geological research which is in the Perdana Industrial Park North Port Klang, Selangor. All the factors of a good location for our plant is considered before finalizing our plant location. And then lastly, detailed design and mechanical design have been done for all units and compared with the industrial process so that it will be more realistic and productive. That's all from us. Thank you.